When using a battery pack composed of multiple cells in series and parallel, the voltage difference between the cells is called, you guessed it, voltage difference. The difference within a certain range is acceptable, usually within 0.05 volts for static voltage and within 0.1 volts for dynamic voltage. Static voltage is when a battery is resting, and dynamic is when a battery is in use. For battery packs, the voltage between individual cells is one of the main indicators of consistency. The smaller the voltage difference, the better the consistency of the cells and the better the discharge performance of the battery pack. Conversely, the larger the voltage difference, the less consistent the battery pack, and as a result, the discharge performance will be adversely affected. The discharge energy of the battery pack becomes insufficient and it gradually deteriorates as the number of cycles increases. Individual cells do not have voltage differences, but in order to obtain higher discharge rates, capacities, etc., we use multiple cells in parallel and series to form battery packs, where voltage differences may occur. In fact, no two cells are exactly the same, and the capacity, impedance, and temperature characteristics of the cells are always slightly different. This is true even if the batteries have the same model number, manufacturer, and protection batch. In addition, the battery pack is affected by factors such as charging conditions and temperatures, which can cause voltage differences to appear and gradually increase. If we compare a battery pack to a reservoir made up of individual tanks connected together, with the water pressure in each tank being the same, their output will also be the same. And if they are not equal, this will result in the water inside one tank being nearly dry, while the other tank is still full. Without protective measures, the battery pack will pull the voltage of the weaker one lower, or even over-discharge when powering. If there is a BMS or other protection circuit measures, any cell voltage will reach the limit of under voltage protection, and the protection circuit will stop the discharge of the entire battery pack to prevent over-discharge. In other words, the discharge time will be shortened. The main factors affecting the voltage differences are the materials and manufacturing processes used by the battery. Therefore, you should pay attention to the brand from which you are purchasing your batteries. If there is a gap in the voltage of the battery pack, you can correct it with additional equipment, such as with a BMS, balance charging, things like that. Stay tuned for part 2 of voltage differences, how to prevent voltage difference.